Hi class, we are now on chapter 5.6. We are going to be dealing with aqueous solutions, how ionic and covalent compounds differ. So one of the most important differences between ionic and covalent compounds is how they behave when combined with water. As an example, when a substance such as salt or sugar mixes with water, it disperses through the liquid, forming a homogeneous mixture called a solution. That means one layer. You don't see that there's salt molecules in there because they have been dissolved throughout the water. If the liquid is water, it's called an aqueous solution. When this happens, we say that the solid has dissolved. Compounds that dissolve in water are said to be soluble in water. Those that do not dissolve in water are said to be insoluble. Pure water is a poor conductor of electricity. So if you are in strictly water, meaning H2O, and no impurities, which consist of ions, you would not get electrocuted because pure water doesn't carry electricity. It is the ions that build up in your shower, that calcium buildup, and that is what allows a current to flow, is the ions in the impurities in the water. So if we connect a battery and a light bulb to a container of pure water, the light bulb will only dimly be lit. So it will, and in most cases what I've seen is that there is no flow to it, but your book is saying dimly lit. The light bulb will be dimly lit. If we dissolve it in an ionic compound like sodium chloride, the resulting solution conducts electricity. This is what you see here. And I lost my place. Hold on. Resulting solution, much more efficient. Okay, so we add sodium in the sodium chloride. The resulting solution conducts electricity much more efficiently, as evidenced by the bright light. Because of this property, we refer to aqueous ionic solutions as electrolyte solutions and the ionic compounds as electrolytes. So when they talk about Gatorade and electrolytes, this is what they're talking about. Anything that does not have a flow is a non-electrolyte. So a flow of electricity, meaning the light bulb does not go off. So in this case, there's no current flow and there's no current flow. So these would be non-electrolytes, where this one is an electrolyte. Okay. So when ionic compounds dissolve in water, the positive and negative ions are pulled away from each other. So remember, there's a very strong attraction between the positive and negative ions. However, what happens is water surrounds the ions and keeps the attraction to a minimum. If you keep them away, they cannot be attracted to each other anymore. And there's more of attraction to the actual water molecules than there is to the ions. So that's what happens if you drop sodium into water, salt into water. So when the ionic compounds dissolve, the positive and negative ions are pulled away from each other and are surrounded by water molecules. That's what they call hydration. The process of pulling apart the ions as an ionic solid is called dissociation. The dissolved ions help carry electric current through the aqueous solution. As a general rule, covalent compounds do not form ions in water because of the aqueous solution containing only covalent compounds are not electrolytic. So when we're talking about this happening and with the current, we're talking about ionic compounds. Ionic compounds have ions, they have charges and allow them to dissociate like this. Covalent compounds do not carry a charge and cannot be pulled apart like this. So here's an example of another is a silver nitrate. It dissolves in water and it's a strong electrolyte. So it'll pull itself, water will pull it apart just as you see here in the sodium chloride. It will pull it apart and surround itself so that you can see there's a purple one here. The water will completely surround itself so that the green and the purple, they can't come back together. There's a stronger attraction to the water than it is to the chloride ion. So silver nitrate is another one that will completely dissolve in water. It's a strong electrolyte and will carry a current. Which of these compounds does not dissociate in water? Well, if it's covalent, which means nonmetals, it's not going to dissociate. So let's just jump to it's carbon tetrachloride. That is a covalent compound.